2.2 Subsets. Subsets. Set A is a subset of set B, symbolized A, that little symbol there, that means some set of B, if and only if all elements of set A are also elements of set B. The symbol set A is a subset of set B, that's what indicates a subset. If you have a line through it, it's not a subset. So anytime we put a little line through something, we're saying it's not this. Like if I say equal, well, if I want to say not equal, we put a little line through it. To show that set A is not a subset of set B, one must find at least one element in set A that is not in set B. So basically, to have a subset, it's whatever's first set needs to be in your second set. So in example 1, when we need to determine whether set A is a subset of set B, what we're looking for is everything in set A in set B? So it's always your first into your second. So we're looking if everything in our first set is in our second set. So if we look at set A, it's boat, train, plane. That is our first set. So let's see if it's in set B. So looking at set B, we have boat, we have train, and we have plane. So everything in A is in B. That is what we just found. So since that is the case, we can say that A is a subset of B. So those little questions, is everything in set A in set B? Yes, everything in set A is in set B. If you want to say that in a fancy way, this is going to be our fancy talk. So what we're actually saying when we say, yes, everything in A is in B, what we're actually saying is all elements of set A are in set B. Because remember, the things inside, those are called our elements. So we're looking to see all of the elements in the first one, are they in the second one? So it goes set A, then set B. That's why we looked at A first, and then see if that's in B. Proper subset. Set A is a proper subset of set B, symbolized A is a proper subset of B, if and only if all the elements of set A are elements of set B, and set A is not equal to set B. So they cannot be equal, but they need to be proper subsets or subsets. So what we're looking here is let's determine whether set A is a proper subset of set B. So what we're looking for is everything in A. So for a proper subset, we're still asking very similar questions. Is everything in set A and set B? That's our first question we're going to ask. So we have our sets A and B. Let's figure it out. We have jazz. Okay, cool, that's in there. Pop. That's in there. Hip hop. That's in there. So yes, that's true. Now we need to ask ourselves, are they equal? Are the two sets equal? No, they're not equal. They're not the same. One of them has rap and classical, the other doesn't. They're different sets, but they are subsets of each other. Now, because they're not equal and everything in set A is in set B, we can say that this is a proper subset. So yeah, A is a proper subset of B. Now, how we say that using fancy talk? So all elements of A are in B and they are not equal. So they cannot be equal to be proper. They can be equal to be subsets. Proper is just that. It's proper. They can't be the same. Now, if we go back to example 1, that is a proper subset as well as a subset. So it can be both. It could be one of them. It could be none of them. If everything is in the second set and they are not equal, it is proper and a regular subset. If everything's in A is in B and they are equal, they are subsets but are not proper subsets. All right, let's go to part B. Determine whether set A is a proper subset of set B. So first set we have is set A. Our second set we have is set B. So let's ask our questions. All right, is everything in A inside B? Well, let's look. We have A, we have B, we have C, and we have D. So yeah, everything in A is in B. All right, because it's asking for proper, that's where we have to be careful. Are they equal? So now we have to ask ourselves the second question. They are equal. They're the same set. A, B, C, D. It doesn't matter the order. They have the same elements. Therefore, they're equal. So because we answered yes for if they're equal, they are not proper subsets. So we say A is not a proper subset of B. Now, it's not asking this, but is it a regular subset? Yes, this is a regular subset. Because of they're equal, it doesn't matter. It's still a subset. It's just not a proper subset. Number of distinct subsets. The number of distinct subsets of a finite set A is 2 to the power of n, where n is the number of elements in set A. Number of distinct proper subsets. The number of distinct proper subsets of a finite set A is 2 to the power of n minus 1, where n is the number of elements in the set. So we can actually find how many proper and regular subsets we have of a set. So we can actually figure out how many ways can we arrange a subset or a proper subset. Example 3. Number of distinct subsets. Determine the number of distinct subsets for the given set SLED. Then we're going to list all the distinct subsets for the given set SLED. All right, so we're talking about finding the distinct subsets, the number of distinct subsets. So number of distinct regular subsets, that's 2 to the power of n. N is how many numbers you have or how many elements you have in your set. So if we look, we have 1, 2, 3, 4. So we have 4 elements in our set. So we have 2 to the power of 4, which if you have a calculator, just plug it into your calculator. Or you can just do 2 times 2 times 2 times 2, which we get is 16. So there's 16 distinct subsets. That means different subsets of SLED. Now we're going to list them all. So a subset can be equal. Let's just put a little reminder here. So subsets can be equal. Now, if it was asking for proper subsets, it cannot be equal. So our first regular subset is the set itself, SLED. Now that's allowed because subsets are allowed to be equal. It's just proper that are not allowed. Now we start breaking it down into each variety, each variation. So if we have SLED, that's 4. Now let's break it into the threes. So our first triple is going to be SLE. Our next triple is going to be SLD. And our next triple is LED. So if you look, we put all of the threes together, SLE, SLD, and then LED. So just for reference, LED and DEL mean the same thing. The order, it doesn't matter. They're just the members we're talking about. So we have all of our triples. Now let's talk about our doubles. So our first double is SL. Our next double is, so we did SL. Let's do SE. And then if we did SL, SE, we have to do SD. All right, we did all of our S's. Now let's do our E's. So we have ED. Now we're not going to do ES. ES and SE mean the same thing. So we have ED. And then we have LE. All right, we did LE. Now LD. All right, now we have to do our singles. So our singles are just each individual letter. So S, L, E, D. So if we count, we have 14 of them. So that's how we know we're missing a couple. We're supposed to have 16. So if we look at our SLED, okay, that's good. SLE, SLD, LED. What about SED? So if we did SED, which we forgot, and that's okay, we have 15. I want to show you, like, why do we use the formula 2 to the power of n? Well, that helps us find all of our distinct regular subsets. So it's a great way to check your work. That's why we use this. All right, now we're missing one more. If you're like racking your brain of like, what's missing? What is here? I did everything. Well, there's always an empty set. There's always an empty set. An empty set is a subset. Now, why is there an empty set? Let me bust out some algebra for you. So if I did something in algebra like 3x squared plus 4x, if I said that, do you know that there's always a 0 at the end of everything? There's always a 0 at the end of everything. There's always an empty set at the end of everything. It's just like if I had x. Isn't there always a 1 in front of x? We just don't put it. That's the same thing with equations. There's always a 0 at the end of every expression, every equation. We just don't put it because 0 means nothing to us. Well, that's the same case. There's always an empty set, which kind of means nothing, which 0, that's what that means to us. So don't forget, your last subset is going to be your empty set. All right, so the symbols we have element. It looks like an E, so that stands for element. We have subset, which we just learned. And then it's not here, but we also have proper subset, which is just the line without the line underneath, or the C without the line underneath. All right, let's talk about part A. So part A, we have, what is this saying? Well, it's saying 3 is an element of 3, 4, 5. That's true. So that's true because 3 is in there. That's an element of that. It's true. All right, now we have B. B and A look almost the same, except now this is set 3. A is just regular 3. So what we're saying is set 3 is an element of 3, 4, 5. That's false. So this is false because we have set 3. So what this is asking for B is set 3 an element of set 3, 4, 5. You see how it's already sounding different? Because that's not in it. That's set 3. It only has one element in the set. And then to the right, we have set 3, 4, 5. So that's 3 elements in that set. All right, part C. Is set 3 an element of set 3, set 4, set 5? You see how it looks different now? And now it works. It does work for us. So it is. We have set 3, set 3. They exist. Now we have D. So D is asking, is set 3 a subset of set 3, 4, 5? So what it's asking is every member in the set to the left in the set of the right? Let's see. So do we have this member in here? Yes, we do. That's true. So this is true because every element in the first set is in the second set. All right, E. Is 3 a part of 3, 4, 5, meaning a subset? Now, subsets have to be set. Every element in the first set needs to be in the second set. That's not a set. E, that's not a set. So that's false. So, subsets have to do with sets. Those are the braces. Both need to be sets, so your left and your right side need to be sets. Since 3 is not in braces, it is not a set and can't be a subset. Alrighty, part F. We actually just learned that in the previous example. Do we have an empty set in set 3, 4, 5? So is an empty set a subset of set 3, 4, 5? Yes, that's true. We just learned that. So that's true because every set, empty sets are always a part of a subset. All right, example 5, variations of ice cream. Have you ever found yourself at like a froyo place or like a build your own ice cream place, like even Ben and Jerry's, the scoop shops, or Cold Stone, and you see all these ice creams and you see all these toppings? So if you have a whole bunch of different ice creams and a different toppings, that's chapter 11. We're going to figure out how do we find that number in chapter 11. Today, we just have one ice cream and a bunch of toppings. So have you ever found yourself of like going in, you're like, I wonder how many different ways I can put all of this together. You're finally going to learn that. So variations of ice cream. Malik is going to purchase ice cream. To their ice cream, they can add any of the following toppings. So there's only one ice cream you can pick. That's it. But you can add hot fudge, whipped cream, cherries, butterscotch topping, caramel toppings, nuts, Reese's Pieces, M&Ms, gummy bears, and rainbow sprinkles. Right, that's a good ice cream shop to me. How many different variations of ice cream and toppings are possible? All right, so how many different variations? That's talking about subsets. Remember when we did the SLED? We found all the different variations that we can pick and put together all of the letters, all of the elements. So because that stands for subsets, subsets actually stand for 2 to the power of n. So n, in this case, n is how many toppings we're going to have. So n is how many toppings that we get to choose from. There's 10 toppings. So our n is 10. So let's plug it in. We have 2 to the power of 10. Now, if you have a calculator, just do 2 to the power of 10. Or we can do 2 times 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 2. We can write 10 twos. 2 to the power of 10, or 10 twos, we get 1,024 distinct ways. So you could go to this ice cream shop 1,024 times and get a different topping on your ice cream every time. Every time it's going to be different for 1,024 ways.